All right, you guys, we're going to continue our discussion of working with complex numbers. Now we're going to work on multiplying imaginary numbers, okay? So pay attention to this note. The note says you cannot simply, okay, multiply radicals together when they are negative, okay? So if you guys remember, when we first learned about radicals, we may have had something like this, 3 square root of 3 times the square root of 4. And our rule said that we multiplied the outsides of our radicals together and the insides as long as the indexes were the same. So this would have been the square root of 12, and we would have simplified as necessary. When we have our problems like the ones listed here, when the radicands or the expressions underneath your radical sign are negative, you cannot just multiply them together. If you were to do that, this one would be square root of 10. You would lose the negative part, okay? So what we're going to do when we're ever asked to multiply, we're going to split our radicals into their negative and their positive parts and then simplify. That way we don't lose the negative part turning into an imaginary part when we're solving our problem. So the square root of negative 2, I'm going to split that into its negative and its positive part. Okay. I'm going to do the same thing for the square root of negative 5. I'm going to split it into its negative part and its positive part. Okay, I'm going to simplify. So we know that the square root of negative 1 equals I. So anytime I see that, I'm going to put I in its place. So that's going to give me I square root of 2 times I square root of 5. Okay, so then I can multiply the outsides of my radical expressions together and my insides. So this I times I, okay, is I squared. Square root of 2 times 5 is square root of 10. Okay. And what we also know from our definition of imaginary numbers is that I squared is equal to negative 1, okay? So that I squared on the outside of that radical sign, that's going to become negative 1, and then we're going to have square root of 10, okay? The square root of 10 doesn't break down any farther, so we get to leave it the way that it is, okay? Let's try the second one. So we're going to do the same thing. We're going to split our two numbers into their negative parts and their positive parts. So the square root of negative 3 is going to become square root of negative 1 times the square root of 3. Square root of negative 6 is going to become negative square root of 1. Square root of negative 1 times the square root of 6. I'm going to multiply them together. So that's going to be I square root of 3, I square root of 6, which is going to become I squared on the square root of 18, because 3 times 6 is 18. I squared becomes negative 1 on the square root of 18. So let's see. The square root of negative 1, the square root of 18, let's see. It's not perfect, but it may break down. So let's see. 18 can be broken up into 2 times 9, and 9 is 3 times 3. So we can come out in pairs. So we're going to pull out a pair of 3s, and the 2 has to stay behind. So that's going to change our answer. So we're going to have negative 1. The 3 is going to come outside of the radical, and the 2 has to stay behind. Okay? And then we're going to multiply negative 1 times 3, which is negative 3 square root of 2. Cool. All right, let's try the last one. So let me change my color. All right, so we have the square root of negative 7 times the square root of negative 7. So once again, I'm going to break them down into their negative and positive parts. Okay. Negative square root of negative 1 becomes I. And I times I is I squared. And that's going to be the square root of 49, because 7 times 7 is 49. I squared, by our definition, becomes negative 1. And the square root of 49 is 7. So negative 1 times 7 is negative 7. Okay. Cool.